Good afternoon, good evening, and good morning, depending on where you are located at. It's a great pleasure to welcome you today to the third webinar hosted by APQI in 2015. Earlier, we have hosted webinar on varieties of topics. APQI, or the Asia Power Quality Initiative, is an independent platform that aims to build awareness and capacities on issues related to power quality. This pan-Asian platform, supported by national support network partners, continues to carry out activities towards capacity building and awareness creation amongst various stakeholders. We work further to facilitate regulatory and standards initiative in respective countries. We provide a neutral platform for exchange of knowledge and best practices concerning power quality. Our website www.apqi.org, supported by Leonardo Energy, is single largest resource for PQ related information. And we work with a focus on shared learning, transfer and exchange of information, and active engagement in the field. In today's digital world, the sensitivity of plants, process, and equipment demand for high power quality environment. And poor economics and safety. Power quality in the low voltage and medium voltage network and end user premises, especially industries, is largely not measured and unscientifically is not well understood. Specific measurement and verification typically takes place only after end user complaints have been laid or severe abnormalities noticed. Hence, power quality M&V at each end is necessary to understand the actual PQ event and causes of power quality problems and to design effective countermeasures. Power quality measurement is still quite an embryonic market in India and most countries in Southeast Asia. Considering measurement of distortion in voltage or current waveform or distorted power factor, many of the utility metering is based only on displacement power factor and not true power factor. So lack of understanding constrains proactive steps to contain harmonic generation at user level. Different PQ instruments use the same definitions and measurement techniques for various power quality parameters. It is said that you cannot manage what you cannot measure. And this principle certainly holds true for power quality. Keeping the above in mind, I welcome you all on behalf of APQI India to this webinar, Measurement and Verification of Power Quality in Utilities. Our distinguished industry and utility experts from CQ Meters and Tata Power will talk about various issues we face in this domain of PQ M&V. We'll learn how and what to look at for M&V or power quality in utilities, the current status and trend for future. The experts will share their thoughts on above issues. I'm happy to introduce our expert panelists today. Mr. Sanjeev Dhal, Sales and Marketing MNC Security Meters, is an engineering graduate with over 3 decades experience in the field of industrial marketing. He possesses wide experience of metering, EHV, HV and LV switchgear products. He is associated with CQ Meters for last 15 years and presently heading the sales and marketing function in India for the measurement and control strategic business unit. He has active engagement with industrial and commercial sector for revenue management and energy conservation. He leads the business initiative for power quality regulations, policy on harmonics and measurement solutions at the transmission and distribution level in the country. He got accreditation of grade 1 ESCO from BEE for his work on conservation. Our second expert, Mr. Suhas Dhapde, currently head of transmission planning and performance cell at Tata Power Limited. He has over 30 years of experience in various utility functions such as operation maintenance, protection systems, metering systems, and AMI, energy accounting, consumer complaint resolution, call center operations, and others. Especially in AMI area, he has been a pioneer in rolling out a very modern system in Tata Power Mumbai. Few housekeeping measures. During their speaking, all the attendees will be in muted condition. If you have any questions, on your right hand side of the panel there is a chat box. Through the chat box you can put the question, which will be taken up after both the speakers finish their presentation, and after the presentations we will have exclusive session on question and answer. During the question and answer session also you can put your questions into the chat box. And after this event is over, webinar is over, we will be hosting both the presentations as well as the question and answer in tabular form onto the website. I sincerely hope you will experience a good discussion in today's session and look forward to your active participation in future too. Please do participate in the survey on apqi.org. Thank you. Over to our first expert.
Thank you, Mr. Manas. This is Sanjeev Dhal from Secure Meters. I, at the onset, wish to thank APQI, Mr. Manas and Mr. Kunjan for providing this opportunity to talk about the MNB and the trends in metering for power quality. Yeah. Electrical power perhaps is the most essential raw material used both by the industry and the commercial sector, and is a very unusual commodity because it is required as a continuous flow. It cannot be conveniently stored in quantity, and unlike many other things, also cannot be subjected to quality assurance checks before it is used. However, while we are using it, the technology exists to identify and measure, record and monitor the power quality defects. So while we start, let us look at what actually power quality is. Power quality is the concept of powering equipment in a manner which is suitable to the operation of that equipment. And here I like to remind the august audience that any equipment, when is designed, ideally wishes to have a pure sinusoidal wave. We see a lot of power quality problems associated with it, and this is a problem which is manifested in either of the three attributes, voltage, current, or frequency, and they manifest themselves in failure, malfunction, or misbehavior of a system or customer equipments. Just to elaborate onto this aspect, we would have seen that many industrial processes, they count on constant motion of certain mechanical components. When these components shut down suddenly from an interruption, it can cause equipment damage, or it can spoil a product, or have a breakdown, and we can have associated costs related to restart, cleanup, things like that. There's a classic example which comes to my mind when we are talking about PQ problem is of robotic spot welding in an automobile machine. And if that welding machine is missing out onto certain spots in the welding, it's very difficult to diagnose in the absence of the power quality measurement whether this miss is related to the malfunction of the machine standalone or is caused by the simultaneous appearance of a power quality feature, which can be an interruption or dip or transients or whatever it is. So when we come to the voltage quality issues, we see a lot of usual or the terminology which we use in day-to-day language in terms of interruptions, undervoltage, sag, swill, overvoltage, etc. I'm sure most of us would be aware of what these individually means. However, just for reference, if I say sag is a temporary drop in RMS voltage which may last for a cycle to a few seconds. Similarly, swell is a temporary increase. The duration may again be from half a cycle to few seconds, whereas a transient is a high amplitude, short duration millisecond spike which gets superimposed on the normal voltage or current. It's also usually referred to as a spike. And flicker, it's a visible change in brightness of a lamp or a computer screen due to rapid fluctuations in the voltage of the power supply, and this can also have a huge impact onto the productivity of the industry. So all these are the basic voltage quality issues which an industry or a commercial establishment can experience. Before we proceed further, I think it's pertinent to touch base upon the performance class of power quality measurements. As per the standards, there are three classes are defined, which are class A, S and B. The slide on the screen talks about class A, which is that if different equipments or instruments are used on the same signal, they will produce the same result. As a consequence, they must meet the highest performance and accuracy requirements as defined in the standard. Whereas class S and class B instruments are relatively inferior to class A. The standard itself says that class S instruments are useful for statistical survey and contractual applications, whereas class B are primarily for qualitative surveys, troubleshooting, and not usually recommended for in-circuit applications at critical loads or critical installations. Now, what does a power quality meter measure? Information which a meter provides. And while we talk about the parameters, it is important for us to understand how and why are we measuring this and how do they impact onto the industry. Majority of the voltage dips and interruptions would originate in the transmission and distribution system. So, primary responsibility lying with the supplier. However, the harmonic problems are almost always the responsibility of the consumer. It is the harmonic currents that cause problems in installations. And when these currents flow back into the supply impedance, at the point of common coupling, a harmonic voltage is developed. So the meter measures dips, swells, interruptions, under and over voltage and harmonics. The importance here again is that certain type of loads generate typical harmonic spectrum signatures, which can help us in identifying the source. Now, this signature can be related to the number of pulses or path of conduction. This signature also is usually linked to the type of device. And if you look at it, any industry or a commercial establishment will have a variety of non-linear loads. The non-linear loads can be power converters. Steel industry as it is notorious. You have arc furnaces, you can have ballast in high power discharge, mercury vapor lamps in a commercial building, AC to DC power supplies, UPS, and so on and so forth. It is important for the customer to identify whether these events are happening upstream or downstream of the meter, and that is another parameter which is being recorded or provided for by the power quality meter. As we have seen, these power quality events are subtransients to ranging from few cycles to a few seconds. The user must also have displays and configuration tools along with the monitoring system so that he is able to track the accidents, the shutdowns or the problems which he is facing in his plant back to what has happened in the last 10 minutes in my supply side. So were there any transients or were there any interruptions? For that, monitoring system, which preferably should be online, is required. Nonetheless, if it is missing, the meter usually records all these events in its memory and then it can be taken up for analysis offline also. Add to it the meters, power quality meters, because they form a part of the system. More often than not, these meters, they do come with revenue metering functionality also. So a host of communication protocols are supported by the meters, ranging from Modbus, DLMS to the new IEC 61850, which helps the protection engineers in the utility space or the consumer space to form a network and gather the data conveniently. Some geographies do also talk about DNP3, which, if I talk about India, is not very prominent. If we move to the next slide, briefly talks about the power quality problems versus type of industries. Now here I like to just talk about the various effects of the electrical conditions. So if we look at under voltage effect, now the torque produced is proportionate to the square of the applied voltage. If there's a 10% decrease in voltage, the torque will get reduced by roughly 19%. And if this torque produced is less than what is required by the motor or the load at that point, the motor will tend to stall. If not stall, motor may surely heat up, weakening the insulation. And we must not forget that the insulation life is half for every 10% increase in temperature. And this is an indirect loss which is not measured by the industry, caused by an under voltage event. Similarly, when we talk about the voltage sags and dips, sudden and sharp variation in current can cause triggering of protection systems. And if a protection system trips a plant down, God forbid if it's a spinning yarn kind of industry or a rubber industry, apart from the restart up time, the production loss can run into lakhs of rupees. So that is where the criticality of PQ lies. Moving forward to the slide which depicts the typical PQ parameters and the IT-IC curve. This is another set of information which a power quality meter provides. And just to brief the participants on the curve, this is a curve which is published by a committee, a technical committee of Information Technology Industry Council. It is there's a HTTP link which I can share if anybody is interested. This curve describes an AC input voltage envelope which typically can be tolerated by most information technology equipment. And if you look at this curve, it talks about a prohibited region, a no damage region, and a no interruption in function region. The normal information technology equipment will withstand any event in the no interruption in function region, where the duration of the event is much smaller, even though the magnitude appears to be very high. And similarly, in the no damage region, the normal functionality of the equipment, typically a computer or a server, may get impacted, but there will be no damage to the equipment. Now the relevance of this is, in India, when we have a lot of IT centers and IT parks, and there are huge amount of servers and computers, the meter provides this ITIC curves, and you can identify that how many events have happened in the prohibited region, or all the events are away from the prohibited region, thus providing a continuity or assuring a healthiness of the system at all points. Moving on to the next slide is benefits of PQ measurement. Like we talked earlier about, that there are loads which create typical signatures in terms of harmonics, and those nonlinear loads can be identified using the harmonic signature. We are actually able to identify what corrective measures are required in the system. Apart from that, the PQ measurement will support optimization of electrical network and help in the right performance of the protection devices, stating that the protection devices do not malfunction because of a PQ event. Coming over to the challenges and gaps for effective monitoring in India. Pain to say, but I'll dare to say it is still treated as an avoidable burden and a big cost, both by utility and the consumers or the industry. In India, very few things happen in the absence of a mandate, and the regulatory push to the desired level is still missing. A lot of lip service to certain sectors is being provided, sectors as in industrial sectors or commercial sectors. Lip service for power quality in terms of ad hocism by using spot checks and suggesting some solutions to avoid onto or improve onto the power quality features. But the challenge is everybody using a Class A instrument? Are they being used event based, or are they being used on a continuous basis? Just to share with the august audience, I think the Al Khalif Al Burj building in Dubai, it has maybe 100 plus power quality meters installed. Every feeder of that building has a power quality meter installed. But in India, we are miles away. So what do we need? Moving ahead, we do have conventional metering, but now we have a lot of focus of Government of India on renewables. We are talking about solar, we are talking about distributed generation, we are talking about rooftop solars. So we definitely need a strong framework definition to have power quality as a mandate on all interface points of the consumer with the grid. There can be incentives, there can be penalization, which unfortunately is the way we act in India. Unless an issue is incentivized or penalized, the desired focus or attention probably gets missed out. However, the benefits in terms of, if I can monetize them, it will run into maybe billions of rupees. And most of the time, most industries, they struggle a lot when an event happens or when something goes wrong into their manufacturing unit to identify it correctly as a power quality consequence because of lack of metering or monitoring of the power quality parameters. Now, there's an interesting debate and usual confusion probably in some minds that Government of India is talking a lot about smart meters and nobody is talking about power quality in the same breath as they're talking about smart meters. So are smart meters also good enough to take care of the power quality measurement, or how different they are? My next two slides, starting from smart meters, is talking about what exactly is a smart meter. A smart meter primarily is a traditional meter with a built-in WAN and HAN hardware capability. WAN being wide area network and HAN being home area network. It also involves user interface capability. User in terms of a domestic user, so that he is able to look at his consumption in the comfort of his house and interface and interact. And the basic aim of smart meters, the way this technology and this concept came up, was when the developed world was looking at how do we reduce our energy bills, how do we reduce the greenhouse gas impact, how do we involve consumers because of the affluence, their energy consumption per capita is very high. So they said we need to have control and we need to involve the consumer with the electricity spent, and we at the utility end should also be able to control and monitor the trends. So smart meters got evolved. If we go to the next slide, it again talks about what is the additional benefit of smart meters in terms of time of use profiles, so that if you have different electricity tariffs based on time of use and you have a consumer interface, the consumer can, if he wishes to, reduce his load at peak TOU tariffs and change his lifestyle or his load pattern to suit his electricity bill or his pocket. In general, smart meters do not talk about power quality, and also at the level in which they are supposed to get installed, which is the fag end of the distribution stream, a domestic single phase and three phase consumer, probably power quality will be too much of a asking, in my view, in the smart meters for domestic consumers. So smart meters is a very different ball game. This is more for load management kind of things, involving consumers, helping them monitor their consumption on a daily basis and bring about energy conservation and optimization, because providing information helps. We move on to the next slide, which talks about the power quality issues in industries, and these are typical data from US and Portugal sites, where most of the events are less than a second duration. And it is the capturing of these events which is critical and which is done by the meters, displayed onto the online softwares for analysis once the events have happened. If you move on to the next slide, again the emphasis is the same, that if you look at the total spread of the events, I think the graph is very evident that 92% of PQ disturbances disturbances or voltage sags, duration below 2 seconds. Next slide. Quite evident. The key thing here being that measurement, as Mr. Manas also said, you cannot improve on anything unless you measure and monitor that particular thing. So measurement is the first step that we need to measure. And where do we measure? It is not at one end. As a metering guy, I would say it is both at the utility as well as at the user end, because source of power quality is not differentiated. There's one classic example in India where there is, in the state of Tamil Nadu, there's a penalty on HT consumers on harmonic level violation beyond CA guidelines. The other states are yet to catch up on to that. If you go to the next slide, it just explains and reiterates what I had submitted earlier, that at what all points we recommend the power quality measurements to be done. It is both at the utility end and at the consumer end. And the next slide is a typical case of automotive industry. As you can see, the losses, which were estimated to be roughly 31 million, 3.1 crore, down to 45 million. 45 lakhs, 4.5 million. The benefits are simply huge. I mean, I can't emphasize. Sorry, I can't emphasize them any further. And at the end, I will like to make just one submission, that harmonics will stay. It is the amount of the harmonic voltage and current levels that a system can tolerate is dependent on the equipment and the source, and ongoing preventive maintenance programs, including measurement of harmonics and power quality features, can detect problems in the making, eliminating costly failures. Once a user or a utility knows what system harmonic level presently are, we can quickly identify what is the effect of new equipment being added due to these levels, and how much of an increase in harmonic levels this system can tolerate. With that, I'd like to close on to my part of the presentation. Thank you.
Can I start with you? Okay, Good afternoon. This is Suhas Dhapre from Tata Power Company. I would like to thank Mr. Manas, Mr. Kunjan and Mr. Sanjeev, the first speaker, for providing us this opportunity to share our experience in the area of measurement and verification of power quality in the utilities. I would just like to say one slide about our company. Tata Power is India's largest private sector integrated company with a significant international presence and has an installed generation capacity of 8,623 megawatts. It is present in all segments of power sector via the generation, transmission, distribution and trading. Our generation bouquet includes thermal, hydro, solar as well as wind. It's a well diversified company and present in all segments of power sector. Tata Power has a consumer base of over 6 lakh in Mumbai city, and an average of about 6,500 million units are supplied to these consumers annually. Tata Power supplies electricity to many key consumers in Mumbai like oil refineries, international airport, railways, Municipal Corporation of Greater Mumbai, many hospitals, important national research centers like Bhabha Atomic Research Center, and innumerable number of data centers, call centers, etc. Mumbai was always and is always known for 24/7 power supply and has always enjoyed absolutely load shedding free status for the last century. However, what we are observing is the requirements of consumers are changing, constantly changing over a period of time. And is not the only requirement of consumer. Power with good quality is their requirement. Consumers are increasingly becoming aware that the performance and lifespan of the electrical appliances, machines, gadgets which they operate depend on power quality. Also, what we are noticing in the last few years is that apart from power failure complaints and high billing amount related complaints which we often receive at call center, we have also started receiving complaints which are indicative of the customer's annoyance with the power quality. We receive complaints like voltage fluctuations, experiencing low voltage, high voltage, flickers, which usually affect some performance of some equipment and machines in the premise of the consumer. Now, if I want to look at power quality purely from the perspective of a consumer, Mr. Sanjeev spoke to a great length in very technical, analytical way what is power quality. But for a simple consumer who is not necessarily very technically conversant with the concept of power quality, for him, a deviation in supply voltage or supply frequency beyond the permissible limits, which usually and many times may result in maloperation, misbehavior, or failure of his equipment and appliance. This is a very simple definition that in the customer's perspective, power quality has. If you really look at what causes power quality problem, this slide depicts the flow of energy, electrical energy, right from a generating station to a consumer premise. So the electrons flow from a generating station over a transmission line into a transmission receiving station, subsequently to through distribution lines into a distribution substation, from distribution substation to consumer substation, and then from consumer substation to the consumer premise or consumer plant. In this entire gamut of distribution and transmission and generating stations and the electric network, power quality is embedded. Now, what causes power quality problem? Our experience shows that approximately 80% of the electrical disturbances originate within the customer facility or premise. The potential culprits may include large equipment startup or shutdown, improper wiring and grounding, overloaded circuits, non-linear loads which cause harmonics. Now, most of these problems originate within the premise of consumer, but due to lack of awareness, many consumers are not even aware that the problems that he is experiencing are actually generated within his own premise and are in his control. While there are certain internal causes, there are also external causes. About 20% of power quality problems originate within the utilities transmission and distribution system. The most common causes are lightning and switching surges, tripping, equipment failure in the grid. Now this tripping and failure can occur due to a variety of factors, controllable and non-controllable both. Bird faults, bird dropping a wire, tree branch coming in close arcing zone of a overhead transmission line, animals, reptiles creeping into indoor switchgears and switchgear compartments, human interventions, or simply due to aging of the old equipment, ingress of moisture and dust in the equipment. Also, normal switching operations in the grid, when you charge a very large transformer, you experience a power quality issue. There is a sudden dip in voltage. Now, for power quality monitoring methodology, what Tata Power Company has deployed in Mumbai, we have power quality meters installed on all major receiving and distribution substation feeders supplying key consumers. Now, installing power quality meters on feeders is just the beginning. The main area of problem is how and when do you collect the data from this power quality meter and how you handle this data, because this is a large amount of data. So initially, when we were trying to collect the data locally by physically visiting the site and downloading data, it was found to be very time consuming, and in a traffic prone, densely traffic prone areas of Mumbai, it was proving to be a very big task. So we installed a centralized remote power quality meter data acquisition system in the Tata Power Company. This system collects the data remotely from power quality meters installed at field at every 30-minute interval, and we are using our dedicated fiber optic network for this particular activity. So this is a very reliable method of collecting data, and usually we do not experience any problem in this methodology. This data is analyzed further, and the events like voltage sags and swells, flickers, transients, unbalance in voltages, harmonics, frequency deviation, etc., we are checking by just collecting the event data and analyzing the data. The system generates 3 types of reports. One report is a standard report on voltage and current. One report is related to a sag and swell, so it is called a sag and swell report. And there is one report which is generated, which is on the basis of IEC 61000-2-2 standard. The communication options which our system is providing, if you have a single power quality monitor in a station, then we are using a serial port and directly connecting it through a fiber optic FOT switch to our communication panel. Through that it is coming to server. If there are multiple power quality monitors in one station, then we are utilizing the 485 port, daisy chaining it, and then converting it into 232 port, and then collecting the data at the central server. We can also, this equipment installed also has an inbuilt GSM modem through which we can collect the data. It is also possible to install an external modem and collect the data remotely. While we have not usually utilized this because we have a dedicated fiber optic network, but there are certain customer premises from where fiber optic connectivity is not available, we will be using this option of utilizing a modem for collecting data remotely. A typical standard report showing the voltage trend looks like this. Here you will find phase to ground voltage of a 22 kV supply voltage to a particular consumer is tracked, and you can see the red, green and blue for the respective average values of three-phase voltages, and you can see that it is typically varying from a low of 12.2 to 13.4 volts. And this graph typically allows us to check whether the voltage variation is within the band as permitted by the regulatory guidelines. This is a typical Sachs-Well report. The green lines actually show the permitted band, and the dots which you are seeing are actually the happenings or the events which are beyond the permissible limit. The colors are as per the phase. So wherever you are finding green dots, they are related to phase 2, and wherever you are finding red and blue dots are related to phase 1 and phase 3 respectively. This is a typical total harmonic distortion report, wherein it shows phase-wise harmonic distortion that is present in the supply, or rather in the customer premise. These are the various norms permitted by various standards which are applicable. For the purpose of bus voltage, which is up to 650.65 kV, that is around LV supply, the permitted band by the Maharashtra Electricity Regulatory Commission is plus or minus 6% from the reference voltage. For systems which are between 650 volts to 33 kV, the permitted band is from plus 6% to minus 9% of the reference voltage. Most of the high tension consumers, commercial and industrial, are usually falling in this band, which are up to 33 kV. 33 kV and above, the permitted band is plus 10% to 12.5%. Very large consumers like railways, Bhabha Atomic Research Center, or pumping stations of Mumbai Municipal Corporation are supplied at 110 kV voltage. So this band is applicable to those consumers. Now, if you compare these norms with respect to the IEEE guidelines, which are related to bus voltage, you will find that for voltages up to 69 kV, the permitted band is 3%. For voltages between 69 kV to 161 kV, the permitted band is 1.5%. And for 161 kV and above, the permitted band is 1%. If you see the CEA guidelines or the Central Electricity Authority guidelines for voltage unbalance, for systems between 400 kV to 765 kV, the permitted unbalance is 1.5%. For 220 kV systems, it is 2%. And for systems between 33 kV to 132 kV voltage, the permitted voltage unbalance as per the CEA guidelines is 4%. The harmonic distortions in the supply voltage, which is permitted as per IEEE norms, 69 kV and below is 5%. Between 69 kV and 161 kV, it is 2.5%, and above 161 kV, it is 1.5%. The THD norms as recommended by CEA for 765 kV system, the harmonic distortion permitted is 1.5%, or a typical harmonic of any particular frequency, it is permitted only 1%, whereas THD can be 1.5%. For systems up to 400 kV, between 220 kV to 400 kV, the THD permitted is 2%, and an individual limit for a specific harmonic is 1.5%. For systems up to 220 kV, it is 2.5% and 2% respectively, whereas systems between 33 kV and 132 kV, the permitted THD is 5%, and an individual harmonic level allowed is up to 3%. The harmonic distortion in current wave permitted as per the IEEE norms is given in this table. This is taken from IEEE and is available for reference on IEEE website. Now, I would like to share with you some of the experiences that we had while interacting with a consumer with respect to the power quality issues. This particular customer is in the segment of automotive and manufacturing. He is actually an industrial consumer and is in the business of manufacturing automotive product. There is a dedicated feeder from one of the transmission receiving stations to this particular consumer, which is in utility language called an express feeder, wherein only he is supplied the power of and it's a dedicated feeder for this particular facility of the consumer. The peak load of this consumer is around 11 MVA, and customer was experiencing voltage sags, and these voltage sags were resulting into tripping of the CNC machines due to under voltage, which was impacting the production, and there was damage observed to some cutter and grinder blades of the CNC machines. This was the problem reported by the consumer. Now we decided to analyze the data from the power quality monitor installed in his premise, and I would like to share with you that this is a pie chart of the causes which found why there was a sag or experienced by the consumer. So you will find that around 19% of the cases of voltage sags were related to problems in the distribution network. About 25% of the sags were on account of were due to the problems in the Mumbai transmission system, while 37% of the faults were in the large grid of the transmission grid, which is the state level grid. The numbers which you are finding in this pie chart, namely 6, 8, 6, 12, they are actually referring to the number of instances of that particular category. This is the data which was collected for a period of 6 months. Now we further analyzed this data, and we found that in one instance, 2 phases were affected. The sag was for a duration of 410 milliseconds. The voltage dropped to 9.204 kV, that is 73.3%. And the reason was there was a tripping of a 220 kV line. While this consumer is fed at 22 kV, a tripping of a 220 kV line in Mumbai transmission system was the basic cause of this voltage sag. And if you go through this entire chart, you will find that most of the trippings in the Mumbai transmission system were the main causes of the voltage sag that was experienced. Also, some faults which are beyond Mumbai, like if you see serial number 10, there was a grid fault between Borivali and Bhandup line of the state grid. There was one instance of this nature. One instance of voltage sag was found on account of tripping of Dabhol-Nagodri line, which is far beyond Mumbai. Both the originating points of this line, Dabhol and Nagodri, are well far off from Mumbai, and yet a tripping of this line, the customer experienced a sag and subsequent damage to an equipment like CNC machine. So what we observe is grid disturbances is one of the main reasons of these voltage sags experienced by some consumers. While there are advantages of having electric grid, but the disadvantage is when you are connected to a grid, any fault or any tripping in a grid, everybody who is connected to the grid will experience this particular phenomena. What we would like to now bring to the discussion is, what do we do with the framework for measuring and verification for PQ by using smart meters. Our first speaker, Mr. Sanju Dal, spoke about smart meters. Our experience in maintaining an individual power quality meter at individual customer premise, installing a communication system, maintaining it and collecting data is a very difficult task, and it requires a lot of resources and monitoring. So while regulators have prescribed power quality norms in supply code, which mandate the utilities to maintain voltage within the specified range and maximum permitted harmonic level at the point of supply. To monitor it effectively, utility needs to install power quality analyzers at each supply point. Now this is a very difficult task, as I said. Now we are looking for an alternative, that how do we collect this data from the customer premise, and can we have an alternative to installing an individual power quality meter at customer facility? Since there is a large scale investment happening in automatic metering infrastructure in most parts of the country, there is a large amount of efforts being put through various APDRP and RAPDRP projects in the area of automatic metering infrastructure. Also, there is a lot of activity happening in the area of smart grid initiatives, and there is a installation of India Smart Grid Forum. A lot of activities are happening in the area of smart grid and AMI. So we would like to suggest that the new standard meters which are being installed, new kind of smart meters which are required to be installed in customer facilities, should also have the features of measuring power quality parameters like sags and swells and unbalance, so that the AMI network which is getting already installed for collecting meter data, the same network can be leveraged for collecting power quality data from a consumer. So from one device we will be able to collect not only the metering data but also power quality data in perhaps the same server, and then it will be easy for us to analyze the meter data as well as the power quality data at the utility end. For this, we feel that a push is necessary from regulatory bodies as well as active interest from various meter manufacturers, so that this power quality measuring and recording facility or feature is included in the smart meter. These specifications which are formed up by the Ministry of Power for smart meter today does not include measurement of power quality as a part of smart meter, but the smart meter for installation at high voltage consumers, particularly 1 MVA and above load category consumers, it will be very great if you have this facility incorporated in the smart meter. The way forward, we feel that in way forward there are certain responsibilities on the regulator. For the regulators, we would like to say that a regulator is required to prescribe standards for power quality in the Indian context. Today our regulatory bodies are driving utilities to follow the IEEE guidelines, but we need to see the Indian context and check what is feasible and what is practical, and develop standards which are on lines of IEEE, but which will take into consideration the Indian context and the condition of the Indian transmission and distribution grids before specifying such standards. I also would like to take this forum to suggest to the government and regulatory forums that they must mandate the utilities to compulsorily install power quality meters to begin with, at least for all high tension consumer installations. They need to encourage utilities, mandate utilities to do this, and also provide them necessary capital expenditure proposals they should approve for installing such power quality meters, as well as a remote data collection and monitoring system for power quality data. Also, regulatory bodies should mandate utilities to provide power quality data to consumer every quarter, so that a quarterly report is given to the HT consumer regarding power quality. This will help in greatly creating awareness in consumer regarding power quality. Also, regulators should prescribe mechanism for incentive penalty in tariff structure for both utility as well as consumer. Such incentives and penalties are already built for power factor. So on the same lines, regulators should have incentives and penalties for going beyond the power quality prescribed norms. If a consumer violates the power quality norm, there should be a penalty. And also there is some incentive if he remains within the power quality band. Similarly, if a utility is not able to maintain the permitted norms of supply quality, then there should be a penalty for utility also. The entire ecosystem which will be required to be set up for making this happen, we will also need independent laboratories which are certified by the government, so that any power quality meter power quality parameter measured by the power quality meter, on the basis of which a penalty is charged to customer. If customer so wishes, then this power quality meter should be tested in a standard laboratory and certified. Such a facility already is allowed by the regulator for tariff meters. Whenever there is a dispute with respect to billing on a tariff meter, a consumer has the facility of registering his request to any third party to get his meter tested, so that they are able to satisfy them through a third-party independent body. Similar facility will be useful when we install power quality meters and use the data of power quality meters for charging penalty or incentive on the basis of power quality norm violation. The responsibility of utility in the years to come would be to install a system for collection and monitoring of power quality data, prepare a quarterly report and provide the same to consumers, and clearly highlight which are the deviations which have happened on the front of power quality, bringing out clearly to consumer, which will help him in identifying the areas which are causing poor quality and take corrective action. Facilitate consumers to analyze and resolve these PQ issues with the help of utility certified power quality consultants or agencies. Since the awareness in India today regarding power quality issues is not very good, it is necessary to involve experts in this field and agencies in this field. They should be certified by utilities so that there is some kind of an accreditation attached to these consultants, and then utilities should recommend such consumers to such agencies for understanding and analyzing their power quality issues and suggesting a solution to resolve them. There is a need also to create a facility to certify PQ meter performance at the request of consumer, as I already mentioned, on the lines of tariff meter. Also, utility need to check the feasibility with meter manufacturers to incorporate power quality measurement features in smart meter, such that installation of separate PQ meter is not required, and the AMI infrastructure which is already being installed by many utilities take care of the power quality data analysis, collection, and remote data collection of power quality. The responsibility for consumer would be improve the awareness about PQ, because at the consumer level, first what has to happen is there must be an increase in awareness about the power quality. Subsequently, consumer need to identify the equipment which cause power quality issues and also take corrective action. This should be the responsibility of consumer. Merely paying penalty month after month is not the solution. I mean, the issue is not to collect penalty or charge penalty. The issue is the penalty should ultimately lead to corrective actions. And that is where we have to educate customer and create awareness in him that once he pays penalty for a month or two, he takes corrective action and does not end up paying penalty on a perpetual basis. Sorry. Procure equipment and appliances which will operate and perform with designed efficiency within the permitted PQ band. While procuring the specifications which the consumer prepare for the appliances or equipment, he must ensure that the band permitted by the regulator and the regulatory norms, the equipment must be designed to perform at its full efficiency within this permitted band of power quality parameters. As a good citizen, it is the responsibility of the consumer not to pollute power system and cause problems to the neighboring consumers. Thank you very much.
Well, Manas here again. We had two good distinct sessions. One covered very well about the meter, the metering class accuracy, and the metering features which are possible today by the technological developments, and which also succinctly brought out that what kind of problem one can face, which is an economic loss for any entity when one can face. And if we can measure, then we can manage. The second one by Suhasji from Tata Power really brought out one of the major power quality issues and challenge which we face all, that is voltage related, the sag issues, and many times it may not be at the control of the distribution company. Besides, another interesting thing we observe that though the HT customers are mainly up to 33 kV, the regulation in the country today exists only above 33 kV. So below 33 kV for the distribution sector, though there is some norms by the state regulatory commission like standard of performance or supply code, but that is not sufficient, and that is quite interesting. So with these remarks, we would get into the question and answer. There are quite a number of questions which we have received. This question there are a number of utilities, especially in Tamil Nadu, where harmonic limitation has been enforced. So the meter specification says that the total kilowatt hour should be sum of fundamental power plus harmonic power. The active power is carried by fundamental voltage and current, and all harmonic power are reactive power. Please clarify.
Can I have the question, please?
Yeah, I will repeat again. The question is from one of the attendee who is telling that in Tamil Nadu there is a enforcement of limitation for harmonics, and the meter specification says that the total kilowatt hour should be sum of fundamental power plus harmonic power. Now the active power is carried by fundamental voltage and current, and all harmonic power are reactive power. Can you please clarify?
Sir, I'll request if you can repeat the question.
Okay, what we'll do, we'll put that question in your chat box, right? So that you will be able to see.
Yeah, please, that will help.
Yeah, have you got it?
Yes, please.
So kindly.
My view is total as well as fundamental energy registers, they should be separately recorded in the meter so that the consumer is not unnecessarily penalized.
Are you familiar with the Tamil Nadu meter specification after the harmonic limitation clause has been introduced?
I'm often not recollecting onto this particular parameter. Have they asked for the two separate registers for total and fundamental energy to be recorded separately? I can check and post in a reply if there's a provision on your website so that everybody is on the same platform.
Yeah, I think that will be a nice gesture. We normally do that question and answer tabulation and host it on the website. So we'll put that to bring in more clarity. But I feel the question also needs little more clarity. So with that, I think we should go to the next question. This is to Suhasji. Are they planning to migrate to the new standards, that is 61004-30?
Actually, as a utility, we do not have the choice of following any specific standard. We are actually awaiting guidelines from the Regulatory Commission regarding the standards applicable, and that is only in the forum of because we as utility is just one utility in the entire gamut of the state of Maharashtra. There are other utilities, and as an entire fraternity of utility industry, the guidelines will have to come from the Regulatory Commission regarding which standard to follow and which standard to what you say utilize for ensuring whether power quality is within which norms. So I think it's the privilege of the Regulatory Commission.
Okay, good. So we come to the next question. This is to Sanjeev ji. Is there any electricity board? I think electricity board is a wrong word in today. there is no more electricity board. That is our history. We should start thinking about, is there any electricity utility or is there any distribution company that has implemented any meters for harmonic or PQ monitoring on a continuous basis?
Not to my knowledge, no.
Okay. So we go to the next question. This is to Suhas ji.
Yeah.
Who bears the cost of OFC and its bills for data transfer?
Can you repeat the question? I have not really understood the question.
Who is bearing, see, you have mentioned that you are collecting the data and then you are getting into the integrated systems through your optical fiber network.
Correct, correct.
So the question is, who is bearing the cost of OFC and its bill for data transfer?
Actually, let me say this optical fiber cable network has been built many years ago, and it is already not used only for power quality data collection. It's a network which is used for distribution management system, distribution automation system, and various other functionalities like protection systems. So it's a common network used for many applications. So there is no specific cost exclusively for power quality meter. In fact, we have not laid any fiber specifically for power quality meter. And the entire measurement system which has been installed along with the power quality monitor, it's an approved capex proposal by the regulatory commission. So the cost is not borne or charged to any specific consumer. It's the cost of included in the ARR of the utility.
And spread over varieties of elements and spread over variety of customers, right?
Correct.
Okay, thank you. Then the next question again to you. This is encouraging thing. It is pleasant to note that Tata Power has PQ meters installed. What is the trend to insist with their HV or EHV customer also to have PQ meters at their end within Tata Power or in general with other utilities?
What I find is there is a good amount of awareness today in EHV consumers. The kind of consumer that we have, the refineries and other, there is a good amount of awareness regarding power quality and understanding. But they largely depend on the utilities for the measurement part. They do not have any plan of installing their own power quality meter because utility has already installed such meters in their premises. But there is a good amount of awareness about the issues related to power quality and the harm that they cause to their system. And they also are willing to take some corrective actions. But at the end of the day, as was mentioned, there is a general aversion to do capital expenditure of large nature into this kind of particular venture. So while there is an awareness, but today as there is no penalty incentive for power quality issues, unless they have some equipment failure or some major problem in their plant, there is not willingness to do any capex investment into taking measures to prevent the impact of power quality.
But as far as metering is concerned, in my opinion, it will not be cost, but at least it will give you the diagnostics to be careful whether you need to take some measure or not.
This particular aspect, as I said, since we have installed the meters, we share the data with them. So therefore, I don't believe they perceive this need separately because ultimately data is available to them through the utility.
Okay. So for other utilities, we have to take that up, right?
Yeah, correct.
Okay.
Because at the end of the day, if you have a power quality meter, I mean, it's a secondary issue whether it is owned by utility or by the customer. But if customer wants to know which facility in his premise is creating power quality, then I believe within his plant he will be required to install power quality meters in his distribution system inside.
Okay. The next question comes to Sanjeev ji. Are there any cost-effective smart meters recording full power quality parameters and which can replace the power quality analyzer? And if it is so, what is the cost level? You can give it from your global experience. Sanjeev ji?
Is this addressed to me, sir?
Yes, sir. Should I repeat the question?
Yeah. A full power quality meter class A. No, it's okay. I've got the question, sir. So just to answer that, today there are meters with class A performance levels with revenue protection and accuracy class 0.2s, and the ballpoint figure of these meters is if it is an industrial and full revenue protection meter, is very close to the existing prices of the ABT meters, which is couple of lakhs. As an indicative price, I think that should be a good reference.
Yeah.
Yes,
so thank you. I think that replies the question specifically. So we go to the next question. This I would request Suhasji to reply, but Sanjeevji, you can also supplement later on. The question is, how do
Yes,
one
sir.
segregate the responsibility of power quality deviations due to the utility or to the consumer?
If you see my presentation, there was one slide which was showing the causes of voltage sag, and we had actually segregated the voltage sags caused due to the faults or trippings of overhead transmission lines in the grid, overall faults in the transmission system within Mumbai city and in the distribution grid. Now, this data we share with consumer whenever there is a complaint with respect to voltage sag, that yes, this particular sag was on account of a tripping in a distribution network or transmission network or a grid. But when we do not have any such disturbance in the system, and yet the customer experiences some voltage sag or dip, then that is when we tell him that probably the reason lies within your premise or within your plant, and it is you who need to really investigate at your end to check why this is happening.
Good, thank you. The next question comes
I'd
to
just
you
like
again.
to,
Yeah, please go ahead.
yeah, what I was saying that is, if a customer or a utility have a meter and preferably a PQ monitoring software, the meters provide an indication for every event whether they are upstream or downstream.
Okay.
So that will be a very clear indication of whether, if it is downstream, it is to the consumer, and if an event is upstream, it is probably from the neighbor or from the supply side. So the meters do have that indication also in terms of the, which side of the meter the event has been detected, upstream or downstream.
So technology helps us today.
Yeah, I think Manas, I would just like to add what you had said.
Especially for
the meters which we have installed also have this facility upstream or downstream. Our experience is sometimes the meter shows it is upstream, but we do not get any information with respect to the tripping in the grid, because the problem is the grid is a vast network, and there are many players in this. So if any tripping occurs at a line which is, let's say, 200 miles away from me, there is some voltage dip. Sometimes, even though the meter shows upstream, it is difficult for us to exactly pinpoint what was that.
Coordinated at SLDC level, basically.
Yeah. SLDC will have to be contacted, and that information has to come, and then we have to check it with the consumer why it was showing upstream. But what Mr. Sanjeev said is very correct. Downstream is a very simple way to know whether the problem is in customer.
And just to add and collaborate on what you have said, Mr. Suhas, probably I was saying differently that probably we also need to check in terms of what is the performance class of the meters which are there, because invariably, see, current issues will always be at the customer side, and which you correctly also said that if there are voltage issues and there are no significant events recorded at the grid level, which means they were so subtransient that probably the protection relays have not got triggered.
There could be a
performance class of the meter problem.
Sorry, ours are class A meters, and sometimes the switching surges may have resulted into this, but then since it is not classified as tripping, in a major grid, it is very difficult to identify such events.
Okay,
Agreed.
that's good. Thank you. So the next question again to Suhasji. As a power utility company, are you insisting on your consumers for voltage and current THD levels as mandated by CEA?
Presently, there are no regulatory, mandates for utilities to, charge any penalty or, for that matter, even provide any incentive to the consumer for either, deviation from a power quality norm or, injection of the high THD into the grid. But, as of now, mostly it is customers complaining to utility and then utility trying to tell them what the problem is. As a utility, let me admit that as of now, there is not much awareness or effort put in by the utilities in India to bring to the customer what is the problem that he is causing to the neighboring community or the consumers in the neighborhood. Because there has to be some regulatory backup. On that basis only, utility can, go to customer and tell him to take some corrective action so that, there is overall improvement in power quality.
Okay. There is another interesting observation, I would say. It is not a question, but it is addressed to Suhasji. The participant is wanting to ask, when the supply from grid fails, then what is the smart meter at the consumer end going to do? From the slide, it was seen that the supply on the grid was off for almost 630 minutes. I think that is not right. 630 minutes is too much. So can you just generically observe this comment?
See, that was a shutdown actually. That 630 minutes was actually an outage. It was an outage.
Yeah.
That has nothing to do with power quality. It's an outage.
Exactly. If it is informed outage, then nothing to do with power quality.
Yeah. So, sometimes it is a outage also due to tripping or some cable fault, but that is on account of the, I would say outage.
Okay. The next question, I would request Sanjeev ji to respond.
And if I can just...
What is the... Yeah. What is the basic difference between 0.2 and 0.2s accuracy meter?
Okay. Before I respond to this, it is just I was adding that onto the outage period. There are power quality indices which are there for the supply utilities in name of SAIFI and SAIDI, which give a comfort to the consumer in terms of the interruptions and the frequency of interruptions which a customer faces. And to the question which you have asked on 0.2 and 0.2s, it's basic differences on the CT accuracy. That it is for lower loads, and the internal design makes composite solution of 0.2s. So it's a special class for the meter.
Okay. Thank you. We go to the next question because we are almost closing towards the end. We'll have another 1 or 2 questions. However, we want to assure the participants that if you have questions and if you have posted it already, they will be collated and answered on the website, which you can always access. Okay, the next question, the way I understood, there are 2 categories of PQ issues. One, the sags and swells, etc., and the other is harmonics and power factor. Which has a more serious impact on the power systems and the end equipment individually? So Suhasji, maybe I would request you to address this.
Actually, the impact of harmonics is felt into overheating of transformers, cables, and generators. So that impact is very slow, and it takes time for anyone to realize what is the impact and what is the damage that is caused. Whereas sags and swells are very easily noticed, and the damage or lack of performance is very immediate in nature, and therefore customer or utility for that matter immediately realizes it that this is because of that. So I think in the long run harmonics are more harmful, and because they continuously come in the system on a day-to-day basis, and therefore the impact on the grid and the equipment is much more harmful due to harmonics. That is my personal view. Whereas sags and swells are by nature temporary in nature.
Let me supplement. If you consider harmonics, it is more like diabetic effect on your body.
Yeah,
if you consider sag and swell, it is more like cardiac arrest. And both for both you will lose the life. So your equipments, your process, individually everybody gets damaged if you have a poor power quality environment. So with that, we go to the next question. Can the tariff meter have PQ metering feature too? I mean, today's generation of tariff meter, can they have PQ metering feature too? Sanjeev ji? Sanjeev ji?
Manas, I can try to answer this question. What I understand is, there are some manufacturers who make power quality features into a tariff meter, but these meters are mostly, from, companies from countries other than India, where the anti-tamper feature requirement in a meter are not so stringent. So, if you have to have a meter in India where the anti-tamper features requirement and also incorporate power quality features into such a meter, that's a task in itself. Whereas if I go to a meter manufacturer in Europe or US, where the requirement of tamper features is not so stringent, if incorporating power quality measurement features at a little additional cost would not be difficult at all.
Okay. So Sanjeev ji, you have anything to add? So please do add.
I was saying that it's not very difficult, as Mr. Suhas said. It is not very difficult to add tamper features and have a point-to-S accuracy revenue meter with tamper protections and Class A performance for power quality. It is only that which Mr. Suhas correctly said, that it's the challenge is on the regulatory side and the push which we need to have onto the utility side in creating or awareness for power quality, because I mean this is not a very difficult task so far as metering is concerned, and one can very quickly have those meters on board. At least from my perspective, if I say so, we can very quickly have these meters offered.
Okay. So that's
it's just the maturity we are waiting for.
Yeah, I think we should take it up with the regulators in a little more persuasive ways, both from the utility as well as from the advocacy side.
I think I would agree with Sanjeev that if you make it mandatory on utilities to install power quality meter in the premise of all HT customers, then what will happen is utilities would like to have a common feature into one equipment, and that is how this whole effort will get driven.
Correct.
As long as it is not mandatory and power quality meter installation is optional, there doesn't seem to be any business case for this particular action.
Okay. So with this we come to the last question. This is again to Suhas ji, but this question consists of so many sub questions. So I would like you to reply but if you feel there is a paucity of time, then what we can do, the reply we can compile and post it. The question is, the meters you mentioned is one of rack type or wall type. The second subsection, is it revenue with PQ measurement or only PQ measurement? The subsection, do they comply with IEC 61430 class A standard? And also, do they record transient recording as well?
Our present PQ meters are actually wall mounted or panel mounted.
Okay.
Actually. And they are performing to IEEE standard.
Okay, IEEE standard.
IEC standard.
Okay. And is it revenue with PQ measurement or only PQ measurement?
No, it is standalone, only PQ measurement.
And do they record transients as well?
Yeah.
Okay, so with that, I think we have covered most of the questions. One or two are left, but we are running short of time on the platform, GoToWebinar platform. So with that, I once again take this opportunity to thank both Sanjeev ji and Suhas ji and my colleague Kunjan and other colleagues on the background who had made this possible to bring to you. We also thank all the participants for having patience and sparing their time, of course, from their convenience, and we look forward to your participation in future. And with that, I wish you all the best and goodbye. Thank you.
Thank you.
Thank you. Thank you, everyone.